Hello, this is Anthony, and I'm glad to be on here today to present on a product supplied by Mezintel, which is called the depth tracking system, and it is targeted for the directional drilling industry. The picture you see there is a minimum configuration of the depth tracking system, which comprises of the following components. There's the gray interface box, which you can also call the data acquisition box. There's also two sensors, the Hookload sensor and the encoder sensor. And Mezintel has been producing the depth tracking system for the last 10 years. And over that time, we've been able to achieve a compact design in such a way that it is very, very portable. The purpose of the depth tracking system is to measure the following: the bit depth and the hole depth, the rate of penetration of the bit as it goes downhole, the hook load on the traveling block, and the weight on bit as felt at the bottom hole. So that's those are the primary parameters, and all the parameters listed there can actually be measured by these two sensors that are shown here with this minimum configuration. Another thing that has been achieved by Mezintel over the last 10 years is commoditization of the product, and by this these are the following features or the benefits that we have been able to achieve. The depth tracking system has been field proven over the years, given the number of or the volume of units that has been sold. We have been able to cost optimize the product. We are using best of breed core parts in the product after several iterations. There's a low number of parts that we assemble to get the system in its present form. And we've been able to achieve fast parts assembly and replacement. So these features or benefits right here have been achieved over those 10 years of product development and sales. Moving forward, here are the 4 topics of discussion regarding the depth tracking system. The first topic will be in regards to sensors, and we have already covered the core sensors from the previous slide, and namely those sensors are the encoder and the hookload sensor. But there are other optional sensors that will be covered as well. Next is the slip switch, and this one used to be provided or supplied as a hardware object. But over the years and with several iterations, we were able to convert this into a virtual switch in the software, and that will be covered as well. Next, on topic number 3 is in regards to the core internal parts of the system. There are only 5 parts that are involved here, which we were able to select over the years and with those iterations, and these ones have been able to give us that compact design. So we'll show how those parts are assembled and how the enclosure appears. So on to the first topic, which is in regards to the depth tracking system sensors. Mezintel groups the sensors in 2 categories. There is the core sensors and there are the optional sensors. The core sensors are the minimum number of sensors that Mezintel recommends to be packaged with the depth tracking system to get those primary measurements that were listed before on the previous slide. The core sensors were looked at before, and there's the hookload sensor, and what this sensor does is that it measures the tension of the cable that supports the traveling block, and in that way it's able to capture the hook load and the weight on bit, which is a derived measurement. The next sensor, which is a core sensor as well, is the encoder sensor, and this is a rotation style sensor. And what it does is it picks up the rotation of the drawworks drum, and it converts that into movement of the pipe, and henceforth the bit depth. Regarding the optional sensors, these are as follows. There's the RPM sensor, which is a proximity style sensor, and what this does is it measures the rotation of the drilling pipe, and the way it's done is that this sensor is attached to the rig floor, and it is in proximity to a bolt or a protrusion from the drill pipe, and as the drill pipe rotates, this sensor counts the number of revolutions over an interval of time to derive the RPM. The next optional sensor is the pump stroke sensor, and this one is a micro switch style sensor, and it's of the whisker style. You can see that whisker rod there, which is a reciprocating rod. And this one measures the number of pump strokes over time to calculate the mud volume that is being dispensed. The other sensor is a pressure sensor, and this one is a standpipe pressure sensor to be exact, and it is attached to measure the mud pressure downhole. The other sensor finally is the geographic encoder attachment, and this one is just a modified encoder which has this geograph fixture, the purpose of which is to measure the linear movement of a cable. It will translate that into rotation of the encoder and henceforth the bit depth. This configuration of the encoder sensor is typically used on truck mounted rigs. Okay. On to topic number 2, and this is in regards to the slip switch for the depth tracking system. So originally Mezintel used to supply the slip switch in the form of a hardware switch, and this has since been discontinued and converted into a software button or a virtual button in the software. Well, the purpose of the slip switch is to disconnect the traveling block from the drill pipe in the software, so that when the block moves, the bit depth stays stationary. If you look at the software interface, the slip switch is implemented using that virtual button that says off right now. Once it is pressed, however, the animation shows that the drill pipe has been disconnected from the traveling block. So if the slip switch is off, it means that the traveling block and the drill pipe are attached, and any movement of the traveling block translates into movement of the bit. And when the slip switch is turned on, then the slips are in, and therefore the traveling block is no longer attached to a pipe, and therefore it will move without a change in the bit depth. Normally the slip switch are indicated as in, so that the traveling block can go and pick up another stand. So it will be traveling up to the maximum point of reach, and then a new pipe stand will be placed so that drilling can proceed. So again, that's how the slip switch is implemented in the Mezintel depth tracking system software. The third topic is in regards to the core internal parts of the depth tracking system. And there are only 5 parts that are hosted by the system, and these are as follows. First, there is the DAC board, or the data acquisition board, and the one chosen is from MCC DAC. The specific model is of part number 1808, and it has a fast real-time clock of 50 megahertz. This same board has an FPGA program which is encoder specific for capturing encoder counts. The second part is a power supply, and this one is from Pulse. This is a 24 volt DC power supply, qualified as a class 1 div 2 device. The third part is a step down regulator, whose purpose is to step down the voltage from 24 volts to 5 volts, and the supplier is Current Logic. The next 2 parts are intrinsically safe barriers, and there are 2 such barriers. There's one for the encoder, supplied by Honor, and the other one is a hook loop barrier supplied by Turk. The purpose of the 2 safety barriers is to control the level of current going to the respective sensors to reduce the likelihood of generating sparks. So these are the 5 core components that make up the depth tracking system as supplied by Mezintel. On to the 4th and final topic, and this is about assembly and enclosure of the Mezintel depth tracking system. We've observed from the previous slide that we have only 5 parts, and those parts are assembled in the manner shown here. There is a panel plate here that holds the components. There's the data acquisition board, and then there's the power supply. The voltage regulator is right behind there, and those two safety barriers for the encoder and then for the hook load sensor. These components are held in place using a DIN rail and L brackets. Once assembled, as shown over there, the panel is laid into a pelican case, which has enough depth to support the components, and what you see from the front is just the LED. Since this system is purely software driven, there's no indicators on the box. And on the side of the box, you have the USB connector and the AC power supply cable, and that is that provides 120 to 240 volts. So this is for international application. And on the other side of the enclosure box, you have the connectors for the hook load sensor and the encoder sensor, and this forms the minimum configuration of the depth tracking system hardware. In our next presentation, I'm going to show the software that works with the system, and that concludes today's presentation. Thanks for your time, and see you in the next presentation.